Hi, Geometry. We're going to do 12.3 this week, and then you also have a quiz. So 12.3 is sector area and arc length. And I think in your assignment, it asks you to write answers in terms of pi and rounded to the nearest hundredth. You only have to give me to the rounded to the nearest hundredth. If you want to do both, that's fine, but I'm only checking the decimal approximation. So we have a couple objectives. We're going to find the area of sectors and find arc lengths. And our vocab is sector of a circle, segment of a circle, and arc length. I have a few examples and we'll go through these. So the sector of a circle is a region bounded by two radii of the circle and their intercepted arc. Okay, so this colored in piece here is a sector. I always think of sectors as a piece of pizza. Okay. So when we want to find the area of this, wouldn't it make sense if we found the area of the circle, the whole circle, multiplied by the fractional amount? And that's exactly what we're doing here. Okay, so as you know, area of a circle is pi r squared. And then we're just multiplying it by the number of degrees divided by the full 360 degrees. So this isn't even too difficult to memorize if you needed to memorize it. So the area of sector HGJ, okay? So we'll have pi r squared. So I'm going to take 12 squared times pi, and then I'm just going to multiply it by 131 degrees over 360 degrees. And I'm just going to throw that into my calculator. And I get, I believe, 164. And I think they want us rounding it to the nearest hundredth. So 0.62, and it's area, so it's meters squared. We'll do this one over here. Same thing. We have pi r squared, so we have 5 squared times pi, and then times 25 degrees over 360 degrees. And I'm just going to put that in my calculator. I get 5.45, and that's feet squared. Let's move on to segments. The segment of a circle is a region bound by an arc and its chord. Okay? So to find this area of this segment right here, you need to find the area of the sector, and then, which is the easy part, and then subtract the area of the triangle, which is the easy part if it's a right triangle. If not, then you need to use some other methods. So the ones in your assignment, I think numbers 17 and 18, you need this 30-60 triangle. So I'm going to do one problem, and it's going to have a 30-60 triangle, and we're going 30-60-90 special right triangle, and I'll do it. But I will assure you the quiz does not have any like this, so not to worry you, but you should be able to see what this is about and how to do this. So to find the area of this segment, LMN, and that's, I guess it just means this, I don't know why it's called the segment. Anyways, this segment right here, this colored in portion, we need to find the area of the sector and then subtract the area of the triangle. Well, the area of the sector is just going to be your pi r squared, so 9 squared times pi times 120 over 360. And then we're going to subtract the triangle part. Well, this triangle part is 120 degrees right here. So we can't use 1/2 times base times height until we are using a right triangle. To make it a right triangle, we can cut this in half. Then we have 60 degrees here, 90 degrees here, and then this is your 30. So I'm going to just take that half out here, flip it around so you can see it a little bit better. We'll call this 60, and then this has to be 30. So we can use the special right triangles for this. I do know my hypotenuse, because that's the radius, that is 9. So I know that the one opposite of the 30 degrees, that's this one, is going to be half of my hypotenuse. Okay? So the one opposite the 30 degrees is going to be 4.5. And the one opposite the 60 degrees, as it kind of says here, is going to be that shorter length, not shorter leg, 4.5 times the square root of 3. Okay. Well, now we have where we can do 1/2 times base times height. Okay. So we know this half for the full triangle. If I were to fill in the full triangle, my height stays the same at 4.5. So 1/2 times my height of 4.5. And my base, I have 2 of these 4.5 square root 3's. So I actually have 9 square root of 3 for my full base. So I'm going to multiply that in there. So I need to throw this into my calculator, and it can get kind of rushed. So I have 9 squared pi times 120 over 360. Then I'll subtract my 1/2 times 4.5 times 9 square roots of 3. And I would like you guys to try this to make sure you get it right. You should get 49.75. And we're finding area, so we're going to use centimeters squared. I'm just going over this one problem. Number 16 on your assignment is a right triangle, so you shouldn't have any issues with that one. But do try 17 and 18 because they'll be like this one here. The last thing we're going to talk about is arc length. And again, this one makes sense because you have the circumference of the circle, but just a portion of it. So your circumference is diameter times pi, or radius times 2 times pi. And then you're just going to multiply it by the number of degrees over 360. So to find the length of arc GH, which is right here, I'm going to take diameter times pi. So my diameter is actually 12 times pi, and then I'm going to multiply by 40 over 360. And I'm going to put that in my calculator, and I get 4.19, and the label is meters. It's just a length, it's not an area, so it's not squared. And one last one here, same thing, they want FG, so they want this right here, it's just not colored in. Okay. So diameter times pi, 16 pi, multiply it by 134 over 360. And you should get 18.71 centimeters. Okay, that's it. Let me know if you have any questions.